Hello, this is Aaron Davern, creator of the 5-Minute Math video series. We are looking at the entire 2023 fourth grade STAAR test. You can follow along with a custom item analysis report I created from the state of Texas by grabbing the QR code from the screen or looking at the link in the description. We'll be looking at each item one at a time, so you can use the bookmarks in the video to navigate to a specific item or jump to the timestamp you see on the screen. For number one, we are looking at lines of symmetry. This is TEKS 4.6b in reporting category 3. So we have three shapes here, shape J, K, and L. We need to find shapes that only have one line of symmetry. Okay, so let's take a look. Our lines of symmetry means it's an imaginary line that we can use to cut it in half equally without any overlap here. That doesn't line up perfectly, so I've got a line of symmetry right there in shape J. And that's about it. This is an isosceles triangle, and so we can only cut it into halves equally one way with a line of symmetry. If it was an equilateral, we could do it three different ways. So that's going to be one. K, this is only one line. So K has got one there. It's got one there. Since it's a square, we can go diagonal. So it's got four lines of symmetry. So that's a no. And then shape L is a trapezoid. Yeah, we can cut it this way, but that's it. You can't do it horizontally or the diagonals. So I've got two shapes that work, J and L. So my answer here is D. Let's see how we did across the state of Texas. So we had 59% of our students get this correct. This was the ninth easiest, landed on the easier side. And you can see by the answer distribution of the incorrect answers, 15, 15, 11, there was a good chunk of our students, right, that were, about 41% of our students that it looked like they really didn't know what to do here because the answers were kind of distributed evenly among those threes. It all comes down to this word one and symmetry, right? You need to know that there's only one line of symmetry, and you first need to know what a line of symmetry is. And so this is just a concept that really gets hammered in fourth grade and really doesn't get touched again. So it's essential that they pick this up in fourth grade. A good suggestion here for educators would be to practice lines of symmetry with paper. Have them trace and cut out shapes and fold and physically see what the lines of symmetry are. And that can then transfer, that concrete manipulative can then transfer onto this representation of drawing lines. But let them fold it first. Let them cut these out and just see how many different ways you can fold them without having any type of extra overlap. For number two, we are looking at expanded notation. This is a readiness standard, TEKS 4.2b in reporting category 1. So we have clues here, three clues. And let's take a look at our possible answers here, right? This goes all the way up to the 100,000s. All right. So let's make a little place value chart here. Okay, so there's all my whole numbers. And it goes to the hundredths place. And what I'm going to do is I'm going to write the value for each of them. So it's 100,000. It's 10,000. Students get stuck. They can count how many spaces there are to the left of the decimal, right? That's between the decimal and their spot, and that's how many zeros they have, right? So this 100,000 has got uh, 5 zeros because there's 1, 2, 3, 4, 5 spaces between the 100,000 spot and the decimal. Same with this 1,000. There's 3 zeros, so there's 1, 2, 3 spots. All right, so let's just put 100, 10, 1. Now this is where the decimals get a little bit tricky. I've got 1/10, got 1/100th. All right, so I've got my place value chart. Now our clues, 8 has a value of 8 times, and then that's going to give you the name of the spot. That's the 100th spot. So I'm going to put my 8 right there. 5 is 5 times 10, so I'm going to put my 5 in the 10 spot. 3, it's got 3 in the 1,000, so I will put that right there. So once you build that place value chart, it becomes kind of simple. All we got to do is line them up, right? So you want to make it 0.8 and then build it this way, 3,652. You see we're close, except the issue there is that A, that 8 is in the wrong spot. B, 3862.05. Yeah, that's wrong. That's wrong. So I've got two things wrong with C, or with B. Let's try C. 3652 looks good so far. 0.48. Okay, so let's see, that's looking pretty good. All three in the right spot. Let's check out this one. 341. Nope, that's a problem. 1,652.48. So the problem is that one in the thousand spot. All right, so the only one that worked for us is going to be C. Let's see how we did across the state of Texas. So this one also landed on the easier side. This was the sixth easiest problem. You see we had almost 70% of our students get it correct. The only one that really tripped them up was A. And take a look at A, right? So the issue with A is not the 5 and the 10 spot. That's good. Not the 3 and the thousands. That's good. It's if students were trying to eyeball this really quick without building a place value chart. Look at this 8. This 8 is supposed to be in the hundredth spot, but they've got the 8 in the 10th spot. The 8 should be right there. So this means that students probably kind of got mixed up between the tenths and the hundredth spot. Most likely they just need an opportunity to practice building a place value chart. Maybe you do it slightly differently than the way that I built it like this with the place values underneath. But they need to build something and line up all their numbers because if they're just going to try to eyeball this, they're going to make some simple mistakes. For number 3, we are looking at larger multiplication. This is TEKS 4.4b in reporting category 2. And we just need to multiply these numbers here, right? So Jake has 24 tracks for his model train. Each track is length of 15. What is the total length of the 24 train tracks? Well, each track, right, this means equal groups. And so this is just getting us 2 by 2 multiplication, right? 24 times 15. You can make an area model. You can do partial products if you want. I'll just do the standard algorithm. But that equal groups lets us know we are going to multiply. So that's going to be 5 times 4 is 20. 5 times 2 is 10. Add the 2 is 12. And then I'm just going to write 24 on that second row. And there we go. 360. Our answer here is D. Let's see how we did across the state of Texas. So this one was also tied for the sixth easiest. You see we had 69% of our students, just like the last problem, get this correct. The one that I think is interesting here is 15%. How are we going to get this 39? Well, look, if I don't recognize this as a multiplication problem, simple thing to do is take my numbers and add, right? So take my 24, my 15. I'm only going to add my 24 once because I recognize that it's the same number written twice. And look at that. I've got an answer. So for 15% of our students, they don't necessarily need work with multiplication, or maybe they do, we don't know. They need work with identifying multiplication problems, right? And we need to find all the different ways that they will say equal groups, okay? And each is going to be something uh, that is typically pointing towards having equal groups, right? When each track has the same length, that's an equal group. An equal group lets us know that we need to either multiply or divide, not add. For number 4, we are looking at the base 10 number system. This is TEKS 4.2a in reporting category 1. So we have a multiple select here. We need to select 2 correct answers. And we have this number 2,222. All right, so let's build that out a little bit because we're going to have all of these clues that we need to find because of it. And so what I'm going to do to help here, 2,222. Since I've already got the digits there, I'm going to write the value of each of those, okay? So this is going to be in the thousands place, right? So this is worth 2,000 because it's a 2 in the thousands place. This is in the hundreds place, so it's worth 200 because it's a 2 in the hundreds place. This is worth 20 because it is a 2 in the tens place, and this is a 2 in the ones place, so it's worth 2. You notice how it's just a 2 with some zeros after it, right? So that's going to help us as we move along here. So we've got the first one, the value of the digit in the tens place. Okay, so that's 20, is 1/10, is means equals, the value of the digit in the hundreds place. Okay, 1/10 times 200. Well, let's see. If I take my 200 and I cut it up into 10 equal parts, right? Would I get 20? Yeah, because 20 times 10 is going to equal 200. So that is correct. So that one works, right? Because when the digits are the same, right? If I'm moving to here from the larger spot to a smaller spot, right? It's 1/10 the size. If I go from a smaller to a larger, it's 10 times. Okay, so that one works. We only need to find one more. The value of the digits in the hundreds place, okay, that's 200, is equals 10 times the value of the digit of the thousands place. Ooh, is 200 going to be 10 times 2,000? No, that doesn't work. It's 1/10. If it had said 1/10, we would have been good. So no on this one. The value of the digits in the thousands place, okay, 2,000 is equals 10 times the value of the hundreds place. Hundreds place is 200. If I do 10 times 200, am I going to get 2,000? Yes, because when you go from a smaller spot to a larger spot, it is 10 times. If you go from a smaller to a larger, right, it's 10 times. Larger to a smaller, it's 1/10. Now, the value of the digit in the hundreds place is 200, is 1/10 the value of the digit in the tens place. Now that's if I go by 1/10, that's going to make it smaller, and I need to make it larger to get up to the 200. Then the value of the digit in the ones place, 10, is 2 actually, is 10 times the value of the digit in the tens place. Well, what's the digit in the tens place? That's a 20. Yeah, that doesn't make any sense. 10 times 20 makes 200. It's the wrong way, right? That would be 1/10 would be better. All right, so we found our two answers, first and third. Let's see how we did across the state of Texas. So this was tied for the 10th most difficult. Look, we only got 40% full credit to get the full 2 points, but we did have 44% get the partial credit. So between these two, we had at least 84% of our students get 1 point. That's better than nothing. We don't know which of these answers they selected that were incorrect. All we get from the state item analysis is whether they got full credit, partial credit, or no credit. This was a difficult standard. 4.2a has only been tested one other time before this in 2018. So this is almost a forgotten standard. And it's kind of a big idea for these kids to understand 1/10 and 10 times. We get the 10 times, but we don't really worry about multiplying by decimals. What does that mean to be 1/10 of something? So teachers need to spend quite a bit of time making this very tactile. Probably get out your place value blocks and just spend a lot of time probably with your hundreds, your tens, and your ones, and just talk about what's 10 times, what's 1/10, how you can physically build those, and then that will slowly morph into being able to recognize these in just abstract sentences, right? There's no pictures, there's no visuals here. So we need to go through the concrete, the pictorial, and the abstract, because what we're getting in this problem is just the abstract here. So they need to have some pictures, some representations, right? Maybe some concrete experiences before they're able to tackle this. For number 5, we are representing an unknown quantity. This is a readiness standard, TEKS 4.5a, in reporting category 2. So we have a flower shop. It's got 242 roses, right? And then it sold 128. So let's draw some representations here, right? Let's do some strip diagrams. All right, so it had 242. All right, so let's say that's our total, 242. And it sold, right, 128. Okay, so it sold, let's just say 128. And then on Monday, the shop got some more roses to sell. It now has 150. Okay, so I don't know what this is. I'm going to make that a question mark. Once I figure that out, watch this. I take my question mark, and then what did they say we had? We had the question mark, and then we got some more roses, got some more, and now my new total is 150. Okay, so if I can figure out what this is, right? So 242, I'm going to subtract this part whole 128. Need to regroup. That's going to be 4. It's going to be 1. Okay, so that is going to be 114. All right, so let's put that in there instead of the question mark. 114. So now I have 114, and then the shop got some more, so they added some more. So 114 plus something makes 150. I could also do a subtraction problem here. 150 minus 114, right? And that's going to get me 36. Okay, so R is the number of roses it got on Monday, and that's this one that I found right here. Okay, so what could I do here? Well, look at A. 242 minus 128 equals 114. Okay, check. I did that. That was my very first step. So that works. But then they did the 150 plus 114. Look, that's going to get me, let's see, 200. What's that going to get me? 264? Wow. Yeah, I ended up with 36. So the first part was right. The second part was incorrect. Uh, B's not going to work because I didn't subtract 250, 242 and 150. All right, C works, right? I've got the 242 minus 128. And then there we go. They subtracted the 150 minus 114 to get your 36, right? That is going to work. And then on this one, wow, they added the 242 and 128. They got this really big number. Okay, so my answer here is C. See how we did across the state of Texas. So this was difficult. This was the 12th most difficult problem. But take a look. We almost had as many students pick A as we did pick the correct answer of C. Now, take a look. We see here that we've got the same first step, right? The difference here is simply that operation. Now, my guess at this point is that this first step, right? This is a multi-step problem. Sold, that means subtract. Cool. I'm with you all day long. Kids get that. They had 242, that's a past tense. They sold 128, that's a clear subtraction. But then once we get to here, I have a feeling that rather than actually trying to solve it like I did, rather than drawing a pictorial representation like I did with a strip diagram, they just tried to eyeball it, right? And look at this, got some more? Well, got some more means add, but this is a, right? This is a subtraction problem because we're not necessarily adding, right, the 150 and the 114, which is the difference here, right? We have a missing part, not a missing whole. If we have a missing part, right, because this is our total, that missing part means we need to subtract. So I would highly suggest working with students to draw pictures, right? Solve the problem with strip diagrams. You didn't have to solve the problem, but once I knew that the answer was 36, right, that made this obvious and this not the answer. So we need to help our students take these problems and actually solve them with strip diagrams rather than just trying to eyeball them and looking for keywords, because got some more that can lead to addition unless you realize that it's a part and not the whole. For number 6, we are looking at measurement problems. This is TEKS 4.8C, a readiness standard in reporting category 3. So a school had 30 gallons of lemonade, and the students drank at the dance rink 24 gallons and 1 quart. So how much lemonade does the school have left over in quarts and gallons? Well, here's the thing. It's kind of hard to subtract when you have different units. What we need to know first, right, is In case we don't have it there, 1 gallon equals 4 quarts. So what I'm going to do is I'm going to draw these gallons. Okay, so I've got 30 gallons. So let me just draw 30 circles. 2, 3, 4, 5, 6, and I'll just do 5 rows of that. Okay, so I'm just going to draw a visual representation. Each of these circles is going to represent a gallon, right? So I'm going to get into my quarts in just a moment. Let me get my 30 gallons here. Okay, so the students at the dance drink 24 gallons. Okay, so that means we're subtracting, we're getting rid of those. So let me get rid of 24 gallons, right? So I've got, these are rows of 6, right? So I'm going to take away 6, 12, 18, 24. So that's 24. So, right, I've only got 6 left. And 1 quart. Okay, so that's where it gets tricky. How do we do the and 1 quart? Well, remember that inside each of these gallons is 4 quarts, right? We got that. 1 gallon equals 4 quarts. So I'm going to take this gallon and I'm going to break it up into 4 quarts, right? So let's pretend that that's 4 equal quarts, and I'm going to get rid of one of them. So I'm going to shade the one that I got rid of. Well, what does that leave me with? It leaves me with 1, 2, 3, 4, 5 gallons. And then how many quarts are not, did the students not drink? 1, 2, 3. 3 quarts. So you could almost subtract this like this. You could almost do 30 gallons minus 24 quarts, or 24 gallons, 1 quart. The problem is you can't subtract 1 quart from nothing, right? So you almost need to regroup this. It's kind of a weird way to think about it. Regroup that in 29 gallons and 4 quarts. If you look at it like this, well, that's pretty easy then. 3 quarts and 5 gallons. So either way you do it here, our answer is A. Let's see how we did across the state of Texas. So this was tied for the 5th most difficult. Take a look. Our number one answer is not even correct. More students chose B, 45%, than chose the correct answer of A. So this is what happens when students don't draw a physical representation. They just try to subtract, right? So if I do my 30 gallons minus 24 gallons, right? And then I've got my 1 quart if I want to put it here. I don't know how to regroup. So I don't know. I'm just going to put my 6 gallons there and 1 minus, there's 4 quarts in a gallon, so there's going to be 3, right? So that's probably how students got to that point. They most likely did not draw a picture. Even though there were 30, I would highly suggest having students draw 30 circles or 30 squares or something, some type of array, so that they can see that they can easily take the 24 gallons away from the 30. They're going to have to break up 1 gallon into 4 quarts in order to take 1 quart away, and that's going to leave only 5. For number 7, we are looking at input-output tables. This is a readiness standard, TEKS 4.5b in reporting category 2. So we have the relationship here between the position of a number in a pattern and its value, right? So we need to find the rule. Well, let's see. How are we going to get from position 1 to value 1.5, right? Well, there's 2 different ways we could do it. It's getting larger, right? So when we get larger, we can either multiply or we can add. Okay, so 1 times what makes 1.5? Well, I don't really know decimals in 4th grade, but I know anything times itself. And then 1 is going to be itself, so it's going to be 1.5. And how would I get from 1 to 1.5? Well, I could add, that's going to be kind of tricky. I can add a 5/10, 0.5. So then let's try that for this next one. What happens if I double times 2, 1.5? Well, think of that like a $1.50. $1.50 plus $1.50 makes 3, so that's not going to work. But 2 plus, I've got to line up the decimals here. 0.5 is going to make 2.5. So let's see, can I add 0.5? Yep, 3 and zero point 0.5 is going to make 3.5. 4 and zero point 0.5 is going to make 4.5. So the decimals might have made this a little bit tricky. Ooh, and look at that C right there. That has the zero point 0.5, but it's in the wrong spot. That's in the hundredths place, so we don't want that one. We want D. Let's see how we did across the state of Texas. So this was the seventh easiest, and we saw that we had a big chunk of our students, right, focus on A, plus 1.5. Now, where do we get that 1.5, right? Because if anything would have worked, we would have maybe multiplied 1.5 by the first row. But that 1.5 is simply the first value, and that's the first number that they see. And it's not really going up by 1.5, it's going up by ones, right? If you're looking vertically, right? We weren't supposed to look vertically, we were supposed to look horizontally, so that wouldn't work. But most likely, we've got 22% of our students that just really didn't know how to solve this problem. They didn't know that they needed to look between the two columns, right? And so they just picked a number that they recognized because obviously the correct answer is not anywhere on there. None of these answers are anywhere on that table except for this one. So when in doubt, right, pick a number that you see on the table. But that means that there's a good chunk of these students that still need help understanding what are they supposed to do when they are given a table and they're supposed to find the relationship between the position and its value. For number 8, we are comparing fractions. This is TEKS 4.3D, a readiness standard in reporting category 1. So we have a multiple select here. We need to find two correct answers. And we need to find which fractions are less than the fraction represented in the model. Okay, so they don't give it to us. They're going to make us do a little bit of work. What do I have here? I've got 1, 2, 3, 4, 5, 6, 7, 8 out of 10. 8/10. Okay, so I need to find two fractions that are less than 8/10. Well, take a look at this. I've got three fractions that are already in tenths. So let's check that, right? So 10/10 is greater than 8/10, so that's not what I need. Or I'm looking for something that is less than 8/10. 7/10, right? Since it's the same denominator, I can just compare the numerators. That one's going to work. And then 9/10, that's not going to work. All right, now for these two, we need to make common denominators. So there's a few different ways we can do that, right? So let's take my fifths. One way would be to think 3/5 times something. I'm going to change it into tenths. So 5 times 2 makes 10. So I need to multiply this fraction by 1 to make it equivalent. So it's going to be 2 over 2. Whatever you multiply by the bottom, you multiply by the top. That makes an equivalent fraction. So that's 6/10. So that's 6/10. Okay. Oh, that is less than. So that's going to work. Another way to do it is just to view these as fifths right here, right? So that's 1/5. Just take these bars. 2/5, 3/5, 4/5, 5/5, right? So really, what I shaded here is 4/5, right? And you see this is my 3/5. My 3/5 is less than my 4/5. And so I've already got my two answers. This one's not going to work because this is 4/5, right? This is going to be 8/10. It's equal. So it's going to be my first and my fourth options. Let's see how we did across the state of Texas. So this was the 13th easiest problem here. And we see that we got a little bit more than half with full credit. But if we take the full credit and the partial credit, that's a whopping 90% of our students got at least 1 point. So that's good. And most likely it was this one, right? That's the easy one to kind of figure out because you don't need to change the denominators. We do need to kind of change the denominator here. And so we need to give our students multiple methods, right? So the algorithm right here, right? 3/5 times something is going to equal whatever denominator I'm trying to get it into. Maybe that works for them, but maybe that's a bit abstract, right? Also, we can have them try to find fifths in this. And if they can find fifths in this, then you can visually see, okay, 3/5 is less than the 4/5 that are already shaded. So that's another way that they could do it. And some students prefer number lines, right? So they could build a number line and they can cut it up into tenths, and then they can also cut it up into fifths, and that could be useful as well. And if they don't know for sure, right, we can actually use the graph paper here, right? We can actually cut it out here, and we can make sure that we get, specific tenths, and then fifths, we can count out the number of squares there as well. For number 9, we are classifying 2D shapes. This is a readiness standard, TEKS 4.6D, and reporting category 3. So we need to find a shape here that has exactly one pair of parallel sides and no right angles. All right, so let's draw some of these shapes here. That's going to help us. So a hexagon. Okay, so a hexagon. Right, when we're thinking of a hexagon, we probably are going to think of something that looks like this. This is what we would call a standard hexagon, right? A parallelogram, right? Let's do that over here in blue. Okay, so this is what we think of as a parallelogram, though we know that rectangles and squares and rhombuses are special types of parallelograms. Trapezoid, right, there's a few different ways to draw a trapezoid. Here's a traditional trapezoid like this, right? Um, and then we've got a rhombus. So rhombus is like a diamond, right? If you want to look at it like that, it's a parallelogram that has four sides that are equal. Okay, so which type of shape can have both of these attributes? Well, let's look back at the attributes real quick. We want them to have exactly one pair of parallel sides, right? So we need to know that parallel sides are two sides that if they were extend forever would never intersect. They never get closer, they'd never get farther, right? And you see I've got parallel sides here, I've got parallel sides here, and I've got parallel sides here. So that's not going to work. On my rhombus, I've got two sets of parallel sides. Parallelogram, I've got two sets of parallel sides. But on my trapezoid here, I have just one set of parallel sides. These two are not, because if you extend them, they would intersect. Okay, so my trapezoid works for this one. And then no right angles. Okay, so uh, we're not seeing any right angles here on any of these shapes, though. If I did want to create a special rhombus, like a square is a special rhombus, so that's got right angles. Parallelogram, right, a rectangle is a special type of parallelogram. Those are right angles, right? But for number 9 here, we've got the only thing that really helps us is these parallel lines, and the only thing that has one set of parallel lines is C, trapezoid. Let's see how we did across the state of Texas. So this one landed on the easier side. This was the 10th easiest. 55% of our students got it correct, and you can tell by the distribution of our incorrect answers that if they didn't get it, they were probably close to just guessing. And you see parallelogram, right? If we didn't know what these words mean, parallelogram, right? You're going to see that same word inside of one of the answer selections. So that's probably why that's the most chosen incorrect answer. But really, we need to give our students plenty of opportunities to see the name of a shape, hexagon, parallelogram, trapezoid, rhombus, and be able to draw an example. Because if you could draw an example, that would be helpful, but really they needed to have a firm idea of parallel sides. What does that mean to have parallel sides? And then obviously it's a related term perpendicular. They need to have tons of experience with these two terms because they are not on the reference materials. And so they have to walk into this problem knowing what parallel means, what right angles means, and then how to draw for reference each of these shapes. For number 10, we are representing data. This is a readiness standard, TEKS 4.9a in reporting category 4. So we've got the stem and leaf plot of Imani practicing soccer kicks. Her next distance is 42, and then which stem and leaf plot correctly adds a kick of 42? All right, so we need to figure out where's that 42 going to go. And so let's take a look at our stem and leaf plot, right? This 3 and then a line, vertical line, and then a 2 means 32. So we're dealing with our tens place and we're dealing with our ones place. So a 42, right, would look like this. Now here's the thing. I've already got a 42 right there. So how am I going to add an additional 42? Well, when you need to double up, take a look right here. We see this is the 15. I see this is a 1 and a 5 is 15, and this is a 1 and a 5 also 15. So this is going to end up looking like this. 4 and then a 2. That's the existing 42. Let's add another 42, and then let's add that 48. So we're looking for something that's going to add that 4, and then that 2, 2, and 8, right? And everything else is going to stay the same. We see it. It's right there. And so our answer here is C. Let's see how we did across the state of Texas. So this was the eighth easiest. You see that we have 62% of our students get this correct. Now, I want to take a look at A and D real quick because it shows us that we've got, between the two of them, we've got 15, 15. That's 30% of our students still don't know how stem and leaf plot work. The number we were adding was 42, remember? But if you don't know how that works, you might flip it around and you might think that equals 42. And so that's what we're doing here. On A, we added an extra 24. Okay, so there's only one in the original, so they add an extra one. So they think they're adding a 42, when in fact they're adding a 24. And then down here on D, they're actually taking away the existing 24. So not only did they reverse it, but they took it away rather than adding it. But these two problems, A and D, speak of students still just flipping the stem and the leaf. So that gives us an opportunity to practice correctly building these stem and leaf plots, right? Just give kids 10 numbers, 10 random numbers between, I don't know, 10 and 50, and let them build their own stem and leaf plot. Even make it a matching game, right? You can just do some cards and some matching, and you can have maybe 5 different sets of data with 5 different stem and leaf plots, and they just play like a memory game. And that will really help them with their discrimination. For number 11, we are looking at area and perimeter. This is a readiness standard, TEKS 4.5D, in reporting category 3. So what is the area of a square that has a perimeter of 36? We have to know quite a few things here. First, we need to know that we have a square. So what does a square mean? A square means that we've got all 4 sides the same length. So how can I draw a square that has 36 meters of a perimeter? Well, I need to be able to take my 36 meters of my perimeter, and I need to be able to divide that by 4. I know that because I know that the perimeter of a square, see that very top, is 4 times s, right? So that's the first tricky thing here. I need to say, all right, if I've got 36 as my perimeter of a square, all 4 sides are equal, therefore I can divide it by 4 to find this side length of 1. It's going to be 9. Now, right, I can draw my square, and I'll do here 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's draw it on here. Got 3, 6, 9. So if I wanted to, I could literally count the squares on the inside, but there's no need to do that because I also have a formula for the area, right? So the area is going to be, back to here, of a square. It's going to be side times side. So what's 9 times 9? Well, I've got 9 rows of 9 columns. 9 times 9 makes 81. And so my area is going to be 81 square meters. The answer is A. Let's see how we did across the state of Texas. So this was tied for the third most difficult problem on the test. Take a look. We couldn't even get a third of our students, and as many students chose the correct answer of A as almost chose the incorrect answer of D. So what is it about this problem? Well, we had to relate area and perimeter. Those are two related but separate concepts that sometimes are taught completely separately. Our students used to using the area of something to find the perimeter, or using clues from the perimeter of something to find the area. Sometimes they are taught in isolation, and they're not used to seeing how those two interact on a shape. And then we also have this, look at this 144, right? What was it about this? Well, if you're confused, you can just think that your side length is 36, right? It says 36 meters, but obviously 36 meters is the perimeter, not the side length. But if you think that that's 36 meters, and then you can just add all these up or do 36 times 4, and you're going to get your 144. Now, that's wrong on multiple steps, but that just shows you that there are a lot of students that aren't quite sure how these two interact, and they kind of treated this as a side length and then added it together as if it were a perimeter problem rather than an area problem. So we need to give our students plenty of opportunities of finding the area and perimeter of a shape, using the clues from area to find the perimeter, and vice versa. For number 12, we are modeling division. This is TEKS 4.4E in reporting category 2. So we got Mr. Hanson, he's picking 625 apples from his orchard, and then he put apples into 5 containers. Okay, so what do we have here? Each container has the same number of apples. We got several clues. When we have same number of apples, right, that means we've got equal groups. And when we see equal groups, that means we are going to multiply or divide. That's going to be the two operations that we deal with when we're talking about equal groups. And look at this. We've got picked 625 apples from his orchard. So that is a total. That's the total number of apples that he has. All right, so let's see what we can draw here. So let's say I've got 625 apples. That's my total. He put the apples into 5 containers. Okay, so I can make some containers down here. There we go. There's my 5 containers. Each container has the same number. So which of these could work? Okay, so let me see. Well, I could do 625. And look, I'm just going to split it evenly into 5. So let's do our long division here. So 5 goes into 6. Right, and if we need to keep track, does McDonald's sell cheeseburgers? Divide, multiply, subtract, check, bring down, right? So we divide first into that first number. 5 goes into 6 one time. Then we multiply. 1 times 5 is 5. Then we subtract. There's 1 left over. Check to make sure that's remainder is smaller than the divisor. It is. We bring down just 1 number at a time. Then we divide all over again. 5 goes into 12 twice. 2 times 5 is 10. We subtract. 2, check. Is it smaller than 5? Yes. Bring down the next one. Start all over again. 5 goes into 25. 5 times. 5 times 5 is 25. And there we go. It goes into 125 evenly. So what did we do? Well, we divided our 625 by 5 because there's 5 containers. 625 total apples. And it equaled 125. So that's what we need. We're going to say 25 divided by 5 equals 125. Let's see how we did across the state of Texas. So this was tied for the 6th easiest. You see we had 69% of our students get full credit. Now what it's interesting here is that only 5% got partial credit at one point. So you either knew it or you didn't, right? And so 74% of our students got at least 1 point, but there's a full quarter of our students that were still kind of confused about this. So I would highly suggest uh, always drawing some type of representation, right? Finding words such as same number of apples to realize we're dealing with equal groups, and look to see if you can put it into a strip diagram. Because once you find your total, right, once you find your parts, then the correct operation becomes a little bit more visual for students. If you're just trying to go straight from a word problem to an equation, you're kind of missing that step of drawing a representation. For number 13, we are relating fractions and decimals. This is standard 4.2G, a readiness standard in reporting category 1. So we need to create a mixed number equivalent to this decimal, all right, from our drop-down menus. So take a look. We've got options there, got options in our numerator, we have options in our denominator. Well, let's see what we know about this. Okay, so this is our decimal point is going to be our dividing line right there. So that decimal point is going to be right there. Divide your whole number and your what's going to end up being a fraction, right? Because fractions can be shown as fractions or decimals. So what do I have as my whole number? Well, I've got a 79. So let's grab 79. Don't need to make it harder than it needs to be. It's going to be this next part that's going to be a little bit trickier, right? So what do I have here? I've got 0, 4. So that's going to be 4. Right? There is no, you can write a 0, 4 if you want to, but we don't really write 0, 4. You need to here for place value, but when you're writing a 4 by itself, you don't need to put that 0. The question is what place is that in? Right? So 79.04. We have to know our place value. So this is the tenths place right here underneath that 0. You can write it as 0.1 or 1 over 10. Right? That's one of our big pieces of work in fourth grade is relating those fractions to decimals. This is the hundredths place, right? Because it's 2 spots over, and you can show it as a 0.01 or 1 over 100. So I need that denominator of 100. So let's put our 4, and then we'll put our hundredths, and there we go. That's how we get full credit here. Let's see how we did across the state of Texas. So this was right in the middle of the test. Out of 32, this was the 16th most difficult. You see we had 45% of our students get full credit. That's 2 points. In order to get the full credit, they needed all 3 correct. If you wanted to get just 1 point partial credit, you had to get 2 correct. Because if you only get 1 correct or 0 correct, well, then you are going to get 0 points. That's the no credit. And so I'm hoping a lot of students grab that 79, but then the question is what did they do after that? And I think the biggest issue for some of our students might be, is that 4 tenths? Is that 4 100ths? Uh, the 40ths and 400ths doesn't make much sense. Besides, they just have the digit 4 in there. But this seems like a very straightforward problem. Take this and write it as a mixed number. Now, most likely an issue for some students is a lot of times we'll do this, right? We'll do 0.34. All right, write that as a fraction, or 0.9. Okay, write that as a fraction, right? Or we'll go, backwards. We'll say 79 hundredths, and we want them to write that as a decimal. But when do we ever give them a whole number? When do we make it 10.34? Well, that changes everything. Or do we make it 20 and 9 tenths? So I think students probably need some practice going back and forth between mixed numbers and decimals, and then decimals with whole numbers and mixed numbers, because that might have thrown some of our students off. For number 14, we are adding and subtracting whole numbers and decimals. This is TEKS 4.4a, a readiness standard in reporting category 2. So we have this many people going to a football stadium here in November, and then that number is this much greater than the number who went in October. How many people went in October? All right, so that's kind of the trick there. Are we adding these two, or are we subtracting these two? Well, if we've got 9,292,721, right? And then that number is greater, we're comparing them. So in order to find that other number, right, then that means the other one is going to be smaller. So I'm going to use subtraction, because we use subtraction when we compare. We use addition when we're adding things together, when we're taking two quantities and making them a little bit larger. So we have to identify what is the correct operation here. We do need subtract. After that, it's just a whole bunch of regrouping, right? So that's going to be 2. I can't take 2 from 1, so I need to take 100 here, break it up, leave 6. That's going to give me an extra 10, so now I've got 11 tens. It's going to give me 9 tens. That's a 0. Got to regroup at 10,000. Break it up into 10 1,000s. Now I've got 12 1,000s minus 4 1,000s is 8. 78,092. My answer here is A. Let's see how we did across the state of Texas. So this one was the 16th easiest, but it's still kind of right in the middle there, and it should not shock you that what happens if we add these two numbers? Let's just see. It's going to give me 10. That's 5, 13. That's 6. That's 7. Well, look at that. That answer was almost chosen as much as the correct answer. So this problem does not come down to whether or not students can add or subtract. They can. Because look how low these incorrect answers are that probably had issues with regrouping. The problem is, can they identify the correct operation? And we need to see here that when we say that number was this much greater, right? I mean, let's plug this back in. could we say here that if we wanted to say, okay, October here, so this 92,721 is 14,629 greater than, right? Since we've got these numbers, we literally have these numbers without any type of operations. We can turn into a sentence greater than question mark. Well, does it then make sense to say that 92,721 is 14,629 greater than this one right here? This is where we need to give our students a little bit of opportunity to practice reasonableness and how we justify our answers rather than just doing an operation and finding the correct answer because it showed up. How do we justify our work? Because if we tried to justify C using this type of sentence stem, it's not going to make any sense. For number 15, we are decomposing improper fractions. This is standard 4.3b in reporting category 1. So we've got a model, and they do tell us that it represents a mixed number with a value greater than 1. So they go ahead and give us quite a few clues here. So we're going to have a mixed number. So this is supposed to be a whole right here. We're going to call this 1 right there. And then we can say this is 1, 2 out of 3, 4, 5. Okay, so we can say 1 and 2 fifths, right? We can represent this as 1 and 2 fifths. We can also say, well, these are both broken up into fifths, and I've got 1, 2, 3, 4, 5, 6, 7. So we can represent this as an improper fraction, 7 fifths, or as a mixed number, 1 and 2 fifths. That's what that represents. So now that we're looking at that, let's find two different ways to represent this, right? So we've got this 7 fifths, which is what we're looking for, represented as equations here. So let's take a look here. Remember, when we add fractions, the denominator needs to be the same, but we simply add the numerator. So this is going to be 2 plus 3, that makes 5 fifths, and 1 plus 1 makes 2 fifths. Well, first off, 5 fifths doesn't equal 2 fifths, and you notice what they did here. This 5 fifths is this first part up here, and the 2 fifths is that bottom part. So we don't want that. We don't want that in two different parts. We want 7 fifths altogether. So I've got 4 plus 3 makes 7 fifths. That's good. 2 plus 2 and 1, oh, close, but that makes 5 fifths. So even if I'm not sure what they're asking for here, right? 5 fifths doesn't equal 2 fifths. 7 fifths doesn't equal 5 fifths. Now, this one's a little bit trickier because look, 5 fifths right here, and look, 5 fifths. So that one, at least, the two equal each other, but we want to represent the whole thing, the mixed number, the 1 and 2 fifths, or the 7 fifths. So we're going to have to go down to D to find that. 7 fifths, and this one here is 7 fifths. So our answer here is D. Let's see how we did across the state of Texas. So this was tied for the 12th most difficult, and take a look. A almost had as many students choosing it as we did the correct answer, D. And you see what we did here, right? So this 2 fifths and 3 fifths, that equals the top part, 5 fifths. And then the 1 fifth and 1 fifth equals the bottom part, the 2 fifths. But those aren't supposed to be two separate fractions, right? This is kind of a tricky one because even though they give you this mixed number right here, really what we need to see here is we need to see this as a 7 fifths. Even though it's represented by two different fraction bars, it does represent one entire number. That entire number just happens to be greater than 1. But it is very easy to see why students would struggle and see that, okay, well, I just see that as the top part and that as the bottom part. But this is supposed to represent a mixed number, which is one single number that just happens to be a fraction greater than 1. So we need to give our students plenty of opportunities to see different models for representing mixed numbers and proper fractions, and then just using the clues here, right? 5 fifths doesn't equal 2 fifths. So it's this equal sign that also should have given them a big clue. And so not only do we need to have students represent models for improper fractions and show them as mixed numbers as well, do we ask them to represent them with equations connected with an equal sign that show different ways to break that down, because that is that step that probably messed up some of our students. For number 16, we are estimating fractional sums and differences. This is TEKS 4.3F in reporting category 2. So we have Johan and buying a certain amount of ham and a certain amount of turkey. So we need a reasonable estimate. So we see right here, we don't need the exact answer, right? We want to estimate here the total amount of ham. Okay, so we have a part whole here. So we're looking for our total, right? And so we've got this turkey and this ham. So the ham is about 3/16, okay? And that's about 7/16, right? The turkey and the ham. So let's put the ham, let's put the turkey right there. And then the question is what do they equal? Well, if you wanted to add them together, right, you get about 10/16. We need to estimate these things, okay? So let's take a look at some of our benchmark fractions. So let's do this. Let me draw a line here, and I'm going to see if I can just draw it and connect it like this here. And I'm looking for 2, 4, 6, 8, 10, 12, 14. There we go, 16. All right. So if I were to cut this in half, right, I'm going to use different colors here because this is one way we can do this. I would cut this in half, 2, 4, 6, 8, right here. And I would say, all right, there's my halfway point because I'm wanting to find equivalent fractions that we could use to estimate these things. All right, so let's say that's 1/2. Now what I should know is that if I cut my halves in half, I'm going to get fourths. So let's cut our halves in half. Let's get a connect line right there. There we go, that's a little bit better. Now here are the things with halves, right? If you take them in half, you cut them in fourths, so that's 1/4. Now this 1/2 can also be labeled as a 2/4, and then that's going to be 3/4. Okay? If I cut my fourths in half, I'm going to get, let's get the connect line back on, eighths. Right? So we're just going to keep cutting it in half. Each new section in half, right? So that's 1/8, 2/8, 3/8. This is 4/8. So look at that blue line. It's 4/8, it's 2/2, it's one, and it's 2/4. 2/4 and 1/2. So I've got 5/8, 6/8, 7/8, and then all of these are going to be 8/8 or 4/4 or 2/2. I'm down to my very final line, and we'll see it right here. These are my 16ths, and that's what we have at the beginning of this problem, right? I've got a 1/16, 2/16, 3/16, 4/16, 5/16, and so on. And what I want to do here is I want to see, I'm just going to go up here, 16ths, and I'm going to do 8/16, 9/16. What I want to do is I want to take my turkey and my ham, and I want to see, okay, where do those land on here? And what is the closest? Everything seems to be fourth, so what is the closest fourth? Now that I've built my 16ths by cutting a line in half, cutting the half in half, cutting the quarter in half, and then cutting the eighth in half. So I've got a 3/16. Let's find that right here. 3/16 is right here. And look, it's right next to my 1/4. Okay? So I'm going to say my 3/16 is about these squiggly lines means 1/4. Okay? And then let's find, what's the other one? 7/16. 7/16 is right here. And look, it is right next to my 1/2 or my 2/4. So since we're doing fourths, let's do fourths. So let's say that's 2/4. So my 7/16 is almost 2/4 or 1/2. Well, now I can add them, 1/4 and 2/4. That equals 3/4. And that's going to be my answer. It's about 3/4. Okay? It's actually a little bit less than 3/4, right? My 10/16 actually lands right there, a little bit less than 3/4, but about 3/4 is going to be my best answer because these other answers, about 1/4 is way too small. Between 3/4 and 1 pound is actually too big, and between 1/4 and 1/2 right here, it's too small. So about 3/4 is going to be my best answer, B. Let's see how we did across the state of Texas. So this was the seventh most difficult problem. Look, the most chosen answer, C, was not even the correct answer. We had only 34% get the correct answer, and 37% thought it was a little bit bigger than that. This was a difficult problem. Estimating fractional sums and differences is a difficult standard. Probably for our students that chose C, what they did is they just said, okay, so 3/16, 7/16 equals 10/16, and still didn't know where that landed. And as you can tell, they knew it was big, and so they just kind of split the difference here. But the best way to do a fractional estimation here is to round first and then add or subtract second. So obviously you see it took a little while to draw that big number line, cut it in half, but students can do this. We can give them the tools, right, to just cut it in half, and then cut the halves in half, and then cut the fourths in half, label it, and then all the way down to the 16ths. Once they do that, you can use this tool, but it takes a little while to build, and that's something we can help our students get experience doing. For number 17, we are looking at expanded notation. This is a readiness standard, TEKS 4.2b, reporting category 1. So it's multiple select. We need to select 2 correct answers. And in which of these does the digit 2 have a value of 2 times 0.1? All right, so let's take a look at what we have here. We got some words, and we've got some digits. And let's go and draw a place value chart. Looks like that's our largest one, so I'll go like this. And I find it helpful to go ahead and just put the value underneath each of these, right? So this is our ones place, it's got a value of 1. This is our tens place, it has a value of 10. This is our tenths place, it's got a value of 0.1, or we can call it 1/10. And this is our hundredths place, it's got a value of 1/100th, 0.01, or 1 over 100. I'm looking for something that has a 2 times, see, this tells you the place, right? So I just want to put a 2 right there. So all we need to do. We're going to find two different answers. So 1 and, okay, this and is the decimal. So when we say 1 and, it's 1.2, but look at this, hundredths. 1 and 2 hundredths looks like this. Now we can't just have a blank there because that's going to look like 1 and 2/10. So we put a 0. That's 1 and 2 hundredths. Or if you want to say in mixed numbers, you can say 1 and 2 hundredths. But I don't need a 2 hundredths, I need a 2/10ths. Okay, so 41 and 2/10ths. So let's build 41, right? And 2, and then they give you the place value that I'm wanting, 2/10ths, so that one's going to work. We can say 41 and 2/10ths is a mixed number. These other three are pretty simple because they give it to you as decimals. That's not going to work. 2.0, not going to work. But then we've got this 10.26. That works because I've got the 2 right where I need it. So it's my second and fifth options. Let's see how we did across the state of Texas. So this question was kind of in the middle of the pack, 15th easiest out of a 32 question test. And we see though that we only had 50% of our students get both points, full credit. And we had another 22 get at least 1 point. So you add those two together, right? You get 72%. Not bad. Here's the scary thing. As we had 27% of our students, that's over 1 out of every 4, could not even get 1 point, which means they couldn't even recognize that this means something in the tenths place and that is sitting right there. I get how this is difficult. So this is probably what messed a lot of our kids up. When we have 1 out of every 4 students can't even recognize that you have a value of 2 times 0.1, that means we need to do a lot more work with expanded notation, right? So we could see expanded notation like this. We can also see it like this, right? So obviously the big work in 4th grade is relating fractions and decimals. But just because we see it like that, how do we find that into a big number like this, right? Are we good at practicing, showing it up like this, right? Because maybe they don't have enough practice expanding it out like this, or maybe they're used to just seeing it in fractions, right? Because what we know is that we can see it as a fraction, and so maybe seeing it in decimal mess them up. We need to make sure that they see it in both different ways. And then obviously, I think this made it much more challenging is trying to convert these two word forms into decimals. So we need to add that in there as well. How do we convert that word form into a decimal form so that we can easily recognize what the place values are? For number 18, we are representing an unknown quantity. This is Readiness Standard 4.5a in reporting category 2. So we have a family paying a total of $44. We got some adult tickets, kids tickets, and the adult tickets cost a total of $20. All right, so we need to figure out how we can best represent this. And first, let's see if we can get rid of any of these because they have the wrong total. We see our strip diagrams. We see our totals here down at the bottom, and they each say 44. Okay, so we can't get rid of that. Now, we've got two adults, so let's just draw a picture here. I've got two adults, say it's a mom and dad, and we got three kids. Okay, so we're going to do two boys and a girl. All right, so what do we know about this? They're going to play mini golf. The two adult tickets cost a total, look at this, of $20. Right now, assuming obviously they're going to spend the same amount on each, right? We can break that down to $10 each, but we don't need to because they give us the total of $20. So let's not get ahead of ourselves. We don't really need to know that. And then we know that the whole thing altogether, right, is $44, right? So we've got this missing amount, and we need to find each child tickets cost, right? So we've got this missing amount, and then we're going to need to take that amount, cut it into three equal pieces, right? So let's see what that is, right? If I've got my $44 for everyone, and I've already spent $20 on my adult tickets, right? $10 for each, that only leaves me 24. So this is going to have to be 24 bucks, but I don't want it all together. I want it by kid. Okay, so let's divide that by 3. All right, looks like it's going to be $8 a piece. And that makes sense, right? We're going to get $10 for adults, $8 for kids. Usually the kids are a little bit cheaper than the adult tickets, so that makes sense. All right, so which picture represents that? Well, I've got my 20 here, and then I've only got two kids. I need three, so that's not going to work. B, I've got my 20, and then I've got, yeah, three kids. Okay, so that looks good. Now look what we have with C and D. I've got two 20s. I don't think so. There's two adults, but it's 20 total. It's $10 each. This costs way too much. Look, this would be $40 right here. So 40 out of your 44 is already used. Like, that's not going to work. So C and D are incorrect because they take that 20, they double it. It's just $20 total. We want to cut it in half into 10 and 10. So no, our best answer here is going to be B. And let's see how we did across the state of Texas. So this is tied for the third most difficult. I mean, take a look. We have almost half of our students choosing this, and you can tell why. They saw two adults, $20, boom, 20, 20. They saw the three kids, each represented by C. We're good to go. They probably spent less than 10 seconds on this problem and moved on. Draw a picture. We need to have our students try to solve the problem on their own. Yes, we are just trying to find a representation, but how's that going to work, right? How's that going to work if you've got $40 tied up here in tickets? So that leaves $4 left for three kids. Do you really think they're going to have a decimal as the ticket price? And why would that be, like 33, right? That's still not even going to get it evenly for you. Why would you have $20 for an adult ticket and a buck 33 for a kid ticket? It doesn't pass the reasonableness test. But most likely students weren't necessarily taking the time to slow down, draw a picture of a family, and figure it out on their own. Because here's the trick, right? You got two adult tickets, but they gave us the total. It's not $20 each. So we need to have our students practice drawing a picture before they get into this representation. Try to solve for C themselves, right? Solve that C is $8. Okay, these are solvable problems. The answer doesn't ask how much does it cost. The answer asks for the representation. But if they take the time to solve the problem first, then you can plug in 8, right? Just plug in 8. How's that going to work? That's too much. That's 24 and 40. That's 64. That's too much. If you know that the answer is 8, all you got to do is plug in 8 for every single C. Only one of these is going to work. So it's going to be better for our students to practice solving the problem first with their own picture before going straight to trying to find the correct representation. For number 19, we are looking at fixed and variable expenses. This is TEKS 4.10a in reporting category 4. So we just need to look at these expenses and make a statement, and hopefully we see the pattern here if we're looking at our columns. Look at that, 25 bucks each every single month. That's what we call a fixed expense, does not change. The book fair, first off, that's a lot of book fairs, right? I don't know if the book fair comes to your school that often, but that's a lot of book fairs. But it changes. So we're going to call that variable because that's what that means. It's changeable, it's unknown. It's going to be high one month, low the next month. So that's what we're looking for. And we're looking for this, right? If we take a look at our options, we see the correct option immediately. School lunches are fixed. Yes. Book fairs are variable. Yes. That's our answer, A. Let's see how we did across the state of Texas. So this was tied for the sixth easiest, and you can see we had almost 70% of our students get it correct. The most chosen incorrect answer is just the flip-flop, right? So it comes down to vocabulary. What does it mean to be fixed? What does it mean to be variable? Thankfully, variable might be a little bit of an unknown word, but fixed, sometimes we talk about fixed when something is broken, but we also talk about something fixed when it is stable and not moving, like we fixed something to the wall. And so if we just give our students a little bit of time with vocabulary and making sure they're using these words when they're talking about personal financial literacy, that will help them because there's not really any calculation required on this text. It just comes down to knowing what these words mean. For number 20, we are multiplying with area models. This is TEKS 4.4c in reporting category 2. So we have to move these numbers and they can be moved into any position. And you can see here that we can actually use each number more than once. So it's really kind of wide open here. What we need to see here is we do have the problem given to us, right? So we've got the picture and we've already got 23 times 15. They've already given us the answer, 345. We're not trying to solve that. We're trying to represent it. Well, let's break this down by our place value, right? So 23 would be a 20 plus 3, and a 15 would be a 10 plus 5. And what we know is that you can multiply, right? The 20 times the 10, the 20 times the 5, the 3 times the 10, the 3 times the 5. That's gets you your partial products, right? And that's what we have here. And take a look. We're going to take these big chunks right here as our tens, okay? So that's going to be our tens. And if you take a look here, right, what we have here is, look, we've got across here, we've got two tens, which means that's going to be my 20 because I've got a 20 and a 3. So my 23 goes right there. Then I've got up and down, I've just got 110. And I've got 1, 2, 3, 4, 5. I've just got that 5 right there, which goes for that right there. All right, so I'm going to put 20 up there, and then a 10 and a 5. And that is how we get our full credit for this problem. Let's see how we did across the state of Texas. So this landed on the slightly easier side, 14th easiest. Here's what I find interesting, right? So we had about half our students get full credit for this. If you get it, you get it. Because especially with this 3 right here, without that 3, it might have been a little bit more difficult. But that 3 really kind of anchored you. Without knowing anything, you could have been like, okay, well, if that's a 3, my 3 is right here, then I'm going to need that 20 right there. You couldn't even put a a 2 there, right? Maybe a 2 there would have been confusing. And then that really kind of opened things up. But take a look at this. We had 42% not get either 2 or 1 correct. They either got 1 or 0 correct. They got 0 points. So you either knew this or you didn't. I mean, this is an area model, and it's called for in the standard. Right? Remember here we are working with standard 4.4c. It's exactly what the standard is asking for, but do our students truly spend enough time manipulating these, building them, even drawing them? Of course, that would take a while. If you ask kids to actually draw this on graph paper, have them draw it out on graph paper, right? It's once they spend time creating some of these, recognize them is going to be a lot easier. But if it's just a matter of recognizing, well, you're just hoping that they get a representation that is similar to one they've seen before. Give them graph paper, give them rulers, and have them draw representations of it. Because once they figure out how that works, then recognizing it's going to be a lot easier. For number 21, we are looking at types of triangles. This is TEKS 4.6c and reporting category 3. So we have these two inline choices here. We have clues about this triangle, one pair of perpendicular sides, and two acute angles. All right, so what do we know about triangles like that? Well, let's just draw it. Perpendicular, right? We need to know that that means we're going to have a right angle. Okay, so I'm just going to kind of draw it right here. Use that blue corner to kind of see. All right, look at that. I've got two sides that come at a square corner, 90 degrees. So that's going to be my perpendicular corner. And I can use these little squares to kind of fill that last line in to make sure that the other two angles are acute. Okay, so what does that mean? Well, acute means it is less than 90 degrees, less than a right angle. So look, that's my right angle right there. So you see how that angle is less. Same with this right here. Okay, so I've got my triangle that fits both of those. Is the triangle an acute, obtuse, or a right triangle? All right. Well, the triangle is, what do I know about those three types of triangles? Okay, so let's increase that a little bit. Those three types of triangles. Well, acute triangles. Okay, I know acute triangles have all three are acute angles. All three are less than 90 degrees. Well, that's not going to work because I've got that 90 degrees right there. Because that's what perpendicular sides make a 90-degree angle. Okay, a right triangle has one 90-degree angle. Okay, and then by definition, the other two are going to have to be less than 90. They're going to have to be acute. And that looks like that's what I've got. The other option is obtuse, and it's got one angle, and that is greater than 90. So let's make it like that. Greater than, okay, so greater than 90. So it's going to be kind of fat like this. Right? If that's going to kind of look something like that, that's more of an obtuse. But really, I'm looking at a right angle. It is a right angle, which makes it a right triangle. It's this one right here. That's what's doing all the work for me, is those perpendicular lines. Why is it a right triangle? Because it has three acute angles? Nope, it does not. An obtuse angle? No, it does not. It has a right angle and two acute angles. That's what makes a right triangle. So that is my correct answer. Let's see how we did across the state of Texas. So this was the 12th most difficult, tied for the 12th most difficult actually. And you can see we actually had a little bit more of our students in the state of Texas get 0 points than actually got the full credit of 2 points. So what made this so difficult? Well, I think it's this term perpendicular, right? So that's a term that sometimes we might not necessarily associate with angles and triangles. We think of it just as lines, but obviously we can have perpendicular sides in rectangles and squares and trapezoids and all kinds of shapes, right? So that's a big word we have to know. And then everything is just written. There's no visuals. You notice how when I solved this, I immediately started drawing pictures, and I even used, right, these lines here. to help me out. So we need to be able to make some visuals here, but I think the biggest connection here is that when I get perpendicular sides, that by definition makes, and I'll draw it down for this one, 90-degree angles. If we can tie those two together for our students, perpendicular equals 90 degrees equals right angles, however you want to define it. They're all the same thing. If we can tie those terms together, right angled 90 degrees, perpendicular sides, that's the connection that we need to make sure our students are aware of. For number 22, we are working with long division. This is TEKS 4.4F in reporting category 2. And so what do we have here? We've got our members of a team. There's 4 members of a team, and they ran the same distance. All right, when I see same distance, I'm thinking equal groups. That makes me think that I'm going to either multiply or divide. That's what equal groups kind of lets me know we're doing. The members ran a combined total distance of, okay, 7,500 feet. Combined distance. So that's my total. So let's draw a strip diagram. Okay, I've got 7,500. Each of the 4 team members ran the same distance. So I'm going to draw a line there, cut it in half, cut each half in half. There I go. I've got my 4 team members, 7,500 total distance. Each of those individual boxes are the same. How many feet did each member run? Okay, how many of the feet did we do? So we're just going to take this 7,500. We are going to divide it by 4, right? So that hopefully is a little bit more clear by looking at this strip diagram here. So we need to make sure that our students here in 4th grade, right, one of the big teachings is long division. The algorithm there, does McDonald's sell cheeseburgers? Right, I use that to keep my steps in line. Divide, multiply, subtract, check to make sure that your difference is smaller than the divisor, and then bring down. Right, a little tricky here because this 4 is going to go into this first digit right there. Sometimes it just goes into the first 2 digits. 4 goes into 7 once. And that's 1 times 4 is 4. Subtract is 3. We just bring down 1 digit at a time. 4 goes into 35 8 times. And this is where we need to know our facts, right? Because if you don't know that 8 times 4 is 32 and 8 times 5 is 40, you have a really difficult time trying to figure out how many times 8 goes into 35 without going over. So memorizing multiplication facts is a 3rd grade standard, so hopefully they know that before 4th grade. If they don't, practice, practice, practice. That's going to be 7, because that's 28. Now we bring down that 0, and we finish it off with a 5. Now, I would highly suggest at this point, we know that multiplication and division are inverse operations, so I want to double check my work. I'm going to multiply this just to make sure I get back to what I need to. That's 20. It's 28 add 2, 30. 32 add 3, 35. All right, so I got back to where I needed to, 1875. C is my answer. Let's see how we did across the state of Texas. So this was the 11th easiest here. We had slightly more than half. Let's check out number or option B here. How did we get that 30,000? Well, remember, when you see each team member ran the same distance, we're thinking equal groups. We're thinking multiply or divide, but let's say we don't draw a strip diagram. So we just think, oh, equal group, same distance. And let's multiply. And guess what we're going to get when we multiply those two? We are going to get 30,000. So we had almost a fourth of our students just choose the wrong operation. So part of it is how do we actually do the long division algorithm? Part of it is how do we recognize it? And I would suggest strip diagram, because if you can represent a strip diagram, it's going to be a little bit clearer that your 7,500 is your total, which means it wouldn't make sense for each of these little subgroups here to be 30,000. For number 23, we are working with measurement problems. This is a readiness standard, TEKS 4.8C in reporting category 3. So Gabby sent 2 boxes in the mail. We got 4 pounds, 1 ounce, 1 pound, 9 ounces. What is the difference? All right, so they're telling us literally we just need to subtract. Difference means subtract. What do we know about these things? Well, if we're not sure, let's go to our reference materials, right? And we're going to look at our weight and mass. 1 pound equals 16 ounces. Okay, so we've got a few different options here. I'll draw a picture first, because what do we have? 4 pounds, 1 ounce. All right, so what I'm going to do here is I'm going to write 1 pound equals 16 ounces. You know what I'm going to do? I'm going to draw a 4 by 4 square. Just going to do it like this. All right, so let's use the connect line. Let's do it. Let's make it official. All right, so that's going to be my pound. All right, so let's draw another pound here. And then we'll draw another pound. And what I'm going to do is I'm going to just have all of these, but then I'm going to need to only draw 1 little ounce left over. Okay, so there we go. Here is my 1 pound, 16 ounces, 16 ounces, 16 ounces, 16 ounces, 16 ounces, right? And I've got 1 little ounce right there. All right, so here's my 4 pounds. All right, so here's my picture. So if I'm needing to subtract, right? So what I could do is I could just take away. First off, I'm going to take away 1 whole pound. So that's gone. Now I need to take away 9 ounces. Okay, so I'm going to start here. I'm going to say 1. Then I'm going to start taking away little ounces. 2, 3, 4, 5, 6, 7, 8, 9. All right, so I've gotten rid of 9 ounces. So what do I have left? Well, this is what I have left. I've got 2 pounds, and I've got up here 8 ounces. All right, so 2 pounds, 8 ounces. That's what's left. The other option here, because here's the thing, we need to regroup, right? We got 4 pounds, 1 ounce. We need to subtract 1 pound, 9 ounces. Well, just like our students learned that we can't take 1 from 9 in regular subtraction, we need to regroup. We need to take one of these pounds. Here's the tricky part. That pound is, remember, 16 ounces. So I need to add 16 ounces to the 1 ounce, so that becomes 17. So it's a weird way to regroup. But once we do that, it becomes 2 pounds, 8 ounces. Or even a third option. We can just take our 4 pounds and we can say, you know, each of those is going to be 16 ounces. So let's just multiply those two, right? And that's going to be 64 pounds or 64 ounces plus the one that's left over right here, right? And then we've got a total of 65 ounces. So this whole thing up here is 65 ounces. And then let's do the same thing with a 1 pound, 9 ounce. Okay, 1 pound, 9 ounce is really 16 ounces plus 9 ounces, right? That's going to be 25 ounces. So let's just subtract this two. 65 ounces. See, now that I've got ounces and ounces, that's an easy subtraction. I've got 40 ounces left. The problem is I need to turn that back into pounds and ounces. Okay, so how many 16s can I get out of there? Well, I can get 2 16s because that's going to make 32, right? So that's going to leave 8 ounces left. So I've got 2 pounds, 8 ounces. Any way you look at it, the answer is C. Let's see how we did across the state of Texas. So we found it. This is the number one most difficult problem on the test, and your eyes are not deceiving you. The lowest percentage answer selection was the actual correct answer. Every other answer selection, A, B, and D, was actually chosen more than this. Now, we start seeing answer selections kind of hovering around 25%, and this is what we get. A whole lot of guessing. So students really didn't have a good idea of how to solve this. Even the 18% that got this, there's probably a significant portion of that 18% that actually guessed that. So students felt very lost on this one. So how do we get some of these answers? Well, if you add 4 pounds and 1 ounce and 3 pounds and 1 pound, excuse me, 9 ounces, guess what you're going to get? 5 pounds, 10 ounce. That's easy, no regrouping necessary. Boom. So if I'm not sure what to do, even though it says difference, that's too hard. Let's just add, there's an answer. If we try to subtract and we're not sure how regrouping works when we're dealing with different units, that's not base 10. Well, what happens when we just say, you know what, forget it. Let's just go back to how we thought subtraction worked when we were in first grade. 4 minus 1 is 3. 1 minus 9 is 8. I mean, that's not how it works, but how often do our students make that confusion and that mistake right there? So that's how we get B. D is where we're not sure of how the different uh, bases work, right? So this is really like a base 16. It's kind of weird, at least from pounds to ounces. So let's say we do want to subtract, but we think it's just that turns into an 11. We think it's just normal subtraction, right? We don't realize that that pound is a unit of 16. We need to add that to the one to make 17. That's where you get your 2 pounds, 2 ounces. So some of this might be guessing. Some of this might be they're actually trying to work it out, right? We just subtracted incorrectly with both B and D. Students need to make it visual. Even though it seems like the numbers are right there, we've got to use this grid paper. We've got to draw and realize, you know what, if I'm going to draw pounds and there's 16 ounces, let me just make a 4 by 4 array. You can make a 2 by 8 if you want to, right? But we need, if we draw this right here to represent our 4 pounds, 1 ounce, right? This turns a seemingly difficult problem to a pretty simple problem. There's my 4 pounds, 1 ounce. If they can see that, then they can easily solve problems like this. So for number 24, we are representing data. This is a readiness standard, TEKS 4.9a in reporting category 4. So we've got a list of the number of hours television is watched by different people, and you see we've got these numbers from 0 up to 15, and they're in order from least to greatest. We need to make a frequency table, and all we're missing is the number of tally marks. Seems pretty straightforward, but there is obviously a little bit of a catch. Take a look here. We've got less than 4, right? So that's pretty simple, right? Less than 4, but oh, look at that. 4 to less than 8. Where does this 4 go? I got 4 on both lines. Well, think, is 4 less than 4? No, that doesn't make any sense. So 4 doesn't go here. 4 is 4. So 4 goes between this 4 and less than 8. So what I'm going to do is I'm going to draw this line right here. I'm going to say I've got 1, 2, 3, 4. That's the trick, is where does that 4 go? So the 4 is going to go right there, and it's go all the way up to less than 8. But look, I've got another 8. So can I say 8 is less than 8? Nope, that's not going to make any sense. So that 8 goes on the next line, this one right here. So I've got 1, 2, 3 on this line. We got to do it again. 8 to less than 12. Less than 12. So this 12 is not less than 12. This 12 is 12. So I have to draw that line to separate it right there. 1, 2, 3. That's the trick. And then I've got my 1, 2 right there. So trying to figure out what happens to this 4, this 8, this 12, right? The 4 and the 8 and the 12, they go on these lines underneath, not the less than 4, less than 8, less than 12. So we're looking for a 4, 3, 3, 2. And we got it down there at D. So let's see how we did across the state of Texas. So this was tied for the 12th most difficult here. We had just a little bit over 2/5 of our students get the correct answer. And you see that C is very similar, right? We've got the same values for the second, third, and fourth row. The only value that's different is really that third row. They've only got 3, whereas the correct answer had 4. Maybe the students that chose C had a difficulty with 0. You see how 0 was one of our numbers. Maybe they omitted that at the very beginning, not realizing that it needed to be included, or they just visually scanned it and just made a mistake. So this is probably going to mean that our students here, when they do these frequency tables here, which we probably think are fairly simple, how many times do we have our students build frequency tables and they have to use these categories that are inclusive or exclusive of a number, like less than 4, 4 to less than 8? That's confusing. So this is another way for our students to practice frequency tables, because typically frequency tables, that should be a pretty high scoring problem. For number 25, we are measuring angles. This is TEKS 4.7c, a readiness standard in reporting category 3. So we need to have angles that appear to have a measure of 160 degrees. Now, hopefully, we can eliminate some of these answers immediately. We should know that a 90-degree angle is perpendicular lines, right? So we'll call that 90 degrees right here. If we extend it all the way out like this, right, that's 180 degrees. That's a flat angle, okay? So my 160 is going to just be a little bit above that 180. So that's going to be about my 160. So it's going to be pretty big. This is going to be an obtuse angle, which means I'm already, let's see, we've got how many answers to choose from? We've got 5 answers. So since we're going to have to scroll up and down, let's go ahead and just make it A, B, C, D, E. I need to find 2, but take a look at this one. I've got my B. See this B right here? That's way too thin. That is a acute angle. And look at that E right there. It's another acute angle. I'm going to automatically get rid of that. So look, now I only have to choose 2 of 3. So I'm looking for 160. So I've visually eliminated 2. How do we find the rest? Well, if I've got one of my rays here on the 0, right? Then that 0 is on the inside. I can measure it by finding the inside value of the other ray, and I've got that 160 right there. So A is good. Okay, so now I'm down to my C and my D, but neither of those happen to have one of the rays on the 0, so that's fine. We just need to subtract the 2. Doesn't matter whether we go inside or outside, because we're going to find they're the same. So let's look at this right there. That's a 160 minus 20. Yeah, that's going to be 140. Close, but not quite. Let's check out our D. Right, so our D here is going to be a 10, and that's going to be a 170. So let's make it 170 minus 10. There we go. That's my 160, so it's going to be A and D, or we want to say option 1 and option 4. That's our correct answer. Let's see how we did across the state of Texas. So this was tied for the 17th most difficult, 16th easiest, kind of right in the middle of the test. We had 50% get full credit here, but we also had 39% get partial credit. That's worth 1 point, right? So between the two, we're looking at 89% getting at least 1 point. That's good, because I think we can easily say it's probably this first option right here that the students really succeeded on. We don't know what the other options, how they played out, but hopefully we can help our students first recognize, right, that 160 is obtuse, so we can eliminate the second choice, we can eliminate the fifth choice, and then obviously we're spending time with them practicing how we find the measure of angles if not neither of the rays are sitting on the 0, how we subtract the 2. It just takes extra practice. For number 26, we are comparing fractions. This is TEKS 4.3d, a readiness standard in reporting category 1. So we just need to find a fraction greater than 1 and 4/9. 2 things that we're going to need to do here. First, you notice they give it to us in a mixed number, and all of our answer selections are improper fractions. So let's go ahead and just change this, right, into an improper fraction. And so we're dealing with ninths, right? So what we could do is we can say 1 and 4/9. Well, this 1 is equivalent to a whole, 1 whole. And since we're dealing with ninths, right, 1 whole is the same as 9/9. So if I've got 9/9 and 4/9, right, we can add those together. We're going to get 13/9. Quick way to do that would be to multiply the whole number by the denominator. 1 times 9 is 9. Add your numerator. 9 plus 4 is 13. Right? And then your denominator stays the same. Either way, I need to compare 13/9 with these fractions. And the only one that really works is A. A is 13/9. 13/9 is not greater than 13/9. The rest have different denominators. We can't compare them if they don't have the same denominators. So now what I need to do is I need to take a look at, let me just go and put 13/9 next to each of these, right? And we need to find one of these that's greater than 13/9. We need to find common denominators, okay? So let's start with B. I'm going to list out my 6's and my 9's. I'm going to find one that's the same on both and take a look. I've got 18. All right, so if I change both of those into 18ths, I can compare them. So the way I do it is I look at it like this. 11/6 times something is going to equal 18. And then I need my 13/9, right, times something. It's going to equal 18. That something needs to be a fraction that's equal to 1, right? So 6 times what makes 18? 3. So if the denominator's 3, numerator's 3, because 3/3 is just 1. So I'm just multiplying it by 1. I'm just making it look different. Multiply straight across. 11 times 3 is 33. So I've got 33/18. And then I've got my 9 times what makes 18. That's 9 times 2 makes 18, so that's 2 halves. So 13 times 2 is 26, okay? So 33/18, right? So I've got 33/18. Looks like that is bigger. Okay, so that might be the one I want. Let's verify that the other ones are incorrect. Let's check out my 11, right, and my 9ths. All right, so I've got 11, and I've got 22, 33, right? And you know what? I can tell you my 11s. I'm not going to get there until I get to 99, right? If we can list all the way out there, sometimes you just have to multiply the two denominators, and it's not going to work until 99. So let's do this. We're going to multiply 13/11 times something to get 99. We're going to multiply 13/9 times something to get 99. Right, so that's 9's. And then 13 times 9, that's going to be, what's that, 117. Okay. And then that's going to be 11. Okay, 13 times 11. That's a little bit harder to do in your head. So let's do 13, 143. All right, so that's 143. All right, so that's less than. So we don't want that, but that's fine. We think B is the answer. Now this 3 is going to be a little bit easier because look, if I do my 3, 6, 9, I can change my thirds into 9, and I don't need to change my ninths. So I'm just going to leave that as 13/9. I'm going to change my 4/3 times something equals ninths. That's going to be 3, 3. Okay, so that's less than. All right, so those are not going to work. So my answer here is B. Let's see how we did across the state of Texas. So we've got 39% of our students getting this correct. This is the ninth most difficult. And take a look. If you were to take about, oh, let's call this 13% away from that and move it down here, guess what you'd get? About 26 and about 26. And you know what that means when you have about 22, 26, 26, 26? Guessing. So even when we do look at this 39%, you can't say that 40% of our students know how to do this. There's a lot of kids that probably just guessed it correct. This was difficult. You saw how long it took me to explain it. Imagine a fourth grader having the stamina and the knowledge to be able to do that. And what made it more difficult is they, added this whole idea of give it to you in a mixed number, but you need to find equivalent fractions that are improper, and everything was improper. How much do we spend time trying to find equivalent fractions, right? Or comparing fractions for like maybe 1/2 and 2/3, right? We need to compare those two. But when do we make them 3/2 and 4/3? Even just making it an improper fraction adds a layer of complexity. So there's nothing that's going to help our students be able to do this other than a lot of practice, right? Just figuring out the algorithm. If you're going to do 1/2 and 2/3, finding that common denominator, so listing out your multiples, and then what is going to make the most sense for them. This is the way I like to teach finding equivalent fractions, right? So they can see it straight across. And maybe, you have a different method, but they just need a lot of practice so it gets into their muscle memory. For number 27, we are looking at two-step multiplication and division problems. This is TEKS 4.4H, a write-in is standard in reporting category 2. So we have a baker ordering flour for 7 batches of donuts. Right, so and the baker uses 4 sacks of flour in each batch, and then the flour comes in crates of 4 into each crate. Okay, so that's a lot of numbers there. I'm not sure what to do, so we need to draw a picture. All right, so ordering flour for 7 batches. Okay, so 15 sacks of flour in each batch. So I'm just going to draw my batches here, and I'm just going to say, all right, 1, 2, 3, 4, 5, 6. Okay, I've got 7 batches. There are 15 sacks of flour in each batch. Okay, or uses 15 sacks. All right, so I've got 7 sets of 15. I could do repeated addition, or much simpler way, let's multiply. What is that? That's 35, 7. Okay, that's 105. All right. So I've need 105 sacks of flour, and the flour comes in crates of 4 sacks. Okay, so I need 105 sacks, and they come in crates with 4 sacks. So I need to get 4s out of here. Right, so here's another way I can do it. I could represent it like this. Right, let's make it green. Right, I could do like, there's my 3. I'm going to do 1, 2, 3, 4, 5. Right, if we literally want to count it out like this, I'm going to represent my 105 this way. So let's do it like this. Just because this next part might be a little bit easier if we haven't. Kind of separate out like this. So what I'm going to do is I'm going to take this. You notice I've got a 3 by 5 array, just because I want this next part to also be visual. And I've got 7 sets of them. So there's my 105, right? I've got my 7 sets of 15. Now, the flour comes in crates of 4. So what I need are sets of 4, okay? So how many sets of 4 can I get? Right? Well, I need, you know, let's get that off. Let's do our draw, right? I need 1 set of 4, 2 set of 4, 3 set of 4, and 1, 2, 3, 4. So I need 4 sets of 4, 5, 6, 7. But you notice there's a little bit left over. It doesn't work out evenly. I can keep doing it this way. Probably a better way would be to say, okay, so I'm going to take my 105. Let's divide that by 4, but you can continue doing it this way, right? I've got 1, 2, 3, 4, 5, 6, 7 so far. All right. And so it's going to end up being a total of, let's see, that's 2, that's 8. Oh, so close. 25. If 26 means I've got 1 left over. Okay. If I get 26 batches or 26 crates, 4 each, look, that's going to get me 104. Right? So this is what I'm doing. I'm doing my 7, 8, 9, 10. I'm going to grab these two, say 11. Then I'm going to say 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I need 1 more sack of flour. So 26 is not going to make it. I need 27. And you notice 26 and 27 are they're both listed. And that's kind of the trick. And this is really asking us to interpret that remainder. I need 26 with 1 remainder, but you can't buy remainder 1. You need 27. Our answer here is D. Let's see how we did across the state of Texas. So this was the second hardest problem. Look, only 30% of the students got it right. You probably guessed it when I was working it out. We're going to get a big chunk of kids that guess 26 is the correct answer and select that. And obviously we're 1 short here, so this is not only figuring out the 2-step problem. You feel for these kids. They did all the work, right? They multiplied 7 times 15, and then they divided that by 4. They didn't know what to do with that extra 1. Now, here's the thing we can talk to kids about. When you see two answers in a problem like this, and they are only 1 away, and you're dealing with division, okay, that's a little bit sus. What that means is, okay, we're dealing with this remainder, and we've got to figure out what to do with it. So that's something we can talk to our kids about. When they're just 1 away, that means we are dealing with a remainder, and we have to interpret it. And we just have to talk to the kids about real life. And that's why drawing that picture with the actual grid might help, because you ask them, what are you going to do with that last one? If they physically see it, they can come up with, well, I guess we need to order, another crate. And that was the correct answer. For number 28, we are relating fractions and decimals. So this is a readiness standard. Takes 4.2G in reporting category 1. All right, so this one is a little bit tricky here because we need to create a decimal that's equivalent, but look, it's an improper fraction. That's why all of our answers here are greater than 1, right? So how do we build this? And unless students have had opportunities with this is probably going to mess them up, right? So this is how I would teach them, right? What is our denominator? Hundredths. All right, so we're going to build a decimal. We're going to go to the hundredths place, and let's label our place value, right? That's the ones place. That's the tenths place. We can label it as a decimal, as a fraction. That's the hundredths place. Label it as a decimal and a fraction. So how many hundreds do we have? 170. We know that each digit can only go in one spot. And as long as they know the final digit here, in this case it's a 0, needs to go in the place that is naming the position, so the hundredth spot, then you just build it from right to left. So you get your 0, next comes your 7, next comes your 1. That's how we build it. That's 170 100ths, 177. I mean, we could say 1.7 tenths, right? And that would be the same thing, 1 and 7 tenths, but we can also say 170 hundredths. And how often do we say that? So we can also add another 0. This is what they do in 5th grade, right? We can also say this is, 1700 thousandths if we really wanted to. And so just getting the kids to see that is going to be helpful. So our answer here is going to be this 1.7, 1 and 7 tenths. The answer is B. Let's see how we did across the state of Texas. So this was the 8th most difficult problem, only 37%. And much like the one just a few problems ago, you take, maybe 12% away from there and add it to there, and you're looking at guessing. So we have a lot of students that were just guessing on this because that doesn't look like anything we've ever seen. When we are teaching the standard, we're relating fractions and decimals. What are we doing? We're asking them to change 7 to 300ths into 0 and 7, 0.73. We're asking them to change, you know, 9 tenths into maybe 0.90. Like maybe we're stretching them and asking them to change it into something that looks like that. But when are we asking them to do this? Improper fractions. How does that turn into a decimal? That's just a new way to look at the standard. And so this is something we're going to need to add to our repertoire as teachers, is giving them practice. I mean, once we teach them how to do it and they have practice, it's not that difficult of building out the place value and just writing your 170 from right to left. You've got your answer right there. Now, obviously, we have to see that we're going to be able to drop that 0 to get the 1.7, but we just need practice. For number 29, we are adding and subtracting fractions. This is a readiness standard, TEKS 4.3E in reporting category 2. So what do we have here? We've got the number of each type of book on Jackson's bookshelf we've shown here. And we need to figure out what fraction are mystery or sports. Okay, so step 1, when we see mystery or sports, that means we're going to add together our mystery and our sports. So how many mystery do we have? Well, it's pretty simple. Look at the key. One book equals one book. So I've got 1, 2 here. Sports 1, 2, 3, 4, 5. Okay, so we add that together. We've got 7, but we need to make it a fraction. So that's going to be our numerator. Our denominator is going to be how many total we have. So I've got 4 comics. So we add that together, we get 7/11ths. So that's our fraction. Seems pretty simple. The difficult part is using our equation editor here. Now, 7/11ths. If we type in 7 and then try to hit this fraction, it's going to think it's a mixed number. So that's not how we do it. And this is one thing that I think is not very intuitive here. You actually have to hit that fraction bar first, immediately get into the fraction. Then you're going to hit your 7. Then you have to select with your mouse the gray denominator. Then you type in your 11. That is your answer, 7/11ths. Let's see how we did across the state of Texas. So this was tied for the fifth most difficult, 33%. And guys, I think this 100% has to do with the test and the testing platform itself. Figuring out how to build a fraction is not intuitive. I don't think our students are going to have that much difficulty turning this into a fraction. Making it work on the equation editor is very difficult. So for this, I would highly suggest obviously doing problems like this, but get them onto a practice test. Get them onto this practice test. Just go straight to this problem and have them practice building fractions. Have them practice, unless you have something that mimics this exactly, they need practice building mixed numbers and fractions in this type of tool so that if they come across this again, they know how to do it. For number 30, we are looking at relative sizes. This is TEKS 4.8a reporting category 3. We just need to find something here that is less than 3 fluid ounces or greater than 3 fluid ounces, less than 1 pint. And so we just have to know these uh, various estimates here. Now, we do get a little bit here on our reference material, so if we want to bring that out, right, we can say, okay, so what do we know? We've got 1 gallon equals 4 quart. We know 1 quart equals 2 pint. We know 1 pint equals 2 cups, and then 1 cup equals 8 fluid ounces. So that may or may not be that helpful for us, right? This is where I would start. This is your gallon. That's a gallon of milk. This is probably the most recognizable thing, okay? So we're looking at, you see this gallon is going to have 4 quarts, right? Each quart is going to have 2 pints, and then each pint is going to have 2 cups. So that's a lot of cups. And so what we're looking at is trying to find something that is, and then I'm not even going to draw the fluid ounces, right? Something that's between 3 fluid ounces and less than a pint. So something that's about a cup, right? Because your fluid ounces are down here. But it needs to be less than a pint. So something down here. So obviously it's not going to be this gallon because that gallon is way up there. It's not going to be this bathtub because the bathtub is going to be bigger than a gallon. You could dump about 40 gallons into a bathtub. Okay, so now we're stuck between A and C, and that eyedropper is so tiny, probably just a few drops. That's going to almost be too small, right? So it's going to be this juice box. It's going to kind of fit right inside there, about a cup. So our answer here is A. Let's see how we did across the state of Texas. So this was the 12th easiest problem. And you notice that for the most part, the state of Texas stayed away from these big ones, right? They kind of got stuck between A and D. So that means that they have a general idea. I think the fact that rather than saying we need something that's exactly 1 cup, this range between 3 fluid ounces and a pint, I'm not sure how often we ask our kids to estimate based on a range. Typically, we say, what is about 1 cup? We give them just a static number. So that means we can help our students practice identifying this range. And I would just pick, a measurement right in the middle of that range. That's why I talked about a cup there. And let them use that as something to estimate against rather than trying to keep that range in their mind. That might be a little bit easier for them. For number 31, we are looking at financial institutions. This is reporting category TEKS 4.10e. We're just recognizing what will hold on to your money and also lend you out money. And there's not much to do here. We're just recognizing The bank will do both. Um, a school does neither. A job, at least, it doesn't lend you money, but it gives money, right? You earn it, but it's not a loan, so that really does neither. A loan at least lends money, okay? So at least lends money, but it doesn't hold onto your money for you. So uh, a job and a school don't do either, and then a loan gives you one, but a bank will do both. So our answer here is A. Let's see how we did across the state of Texas. After 30 problems, we found the easiest problem on the test on the 31st problem. Look at this, 90%. You know, a few students picked loan, which we kind of get because that at least does half the problem. They at least lend you money. But this was very simple, and the state of Texas did it. Just recognizing these financial institutions. Good job, guys. You always want a few softball questions, and we finally found it. For number 32, we are looking at area and perimeter. This is a readiness standard, TEKS 4.5D, reporting category 3. So what we have here is a rectangle, and we just need to find the perimeter. And there's really not anything tricky about this. They give us the measurement, and if we want, we can look at our reference materials. We see the perimeter of a rectangle, right? We can look at it in two different ways. We can say it is either, let's see, we've got this P equals L plus W plus L plus W, or P equals double the L plus double the W. And I'm going to make those capital L's, so it's going to look like a 1. All right, so that's how we find the perimeter. Well, so let's say this is our length. All right, so our length is going to equal 12. And our width is going to equal 8, right? We know that the top is 12, the bottom is 12. If one side is 8, the other side is 8. So I just can substitute in here, right? So P is going to equal 12 plus 8 plus 12 plus 8, right? I'm substituting in my width for 8, my length for 12, or I can say P equals 2 times that, right? So that's going to be 12 plus 2 times my 8. So look at this, guys. That's 20 plus 20. So P equals 40. What do I get over here? P equals 2 times 12 is 24, plus 2 times 8 is 16. It's going to equal the same thing, 40. Pretty straight up there. Our answer here is B. Let's see how we did across the state of Texas. So this was the second easiest, and 79% is still fantastic. It's not as good as the 90 on the previous one, but that's exceptional. You're not going to see a 90% on any other STAAR test for 2023 for any other grade level. So the 79%, we're still very happy about this because it's as straightforward as you can get, right? Now, if we want to add 12 and 8, right, we get the 20. So students didn't know what to do there. They just added the two sides. If we want to multiply 12 times 8, you're going to get your 96, right? I don't know how we're getting 86 unless you multiply, but you don't regroup. But our students did exactly what they should have done. This is a very softball question, teed it right up for them, and they solved it, so good for them.